we're going to be just spending this class today because this is our only class for this week. So we're going to spend it by discussing this one lah. Okay, discussing this exercise exercise questions. Okay, and then we will close this subtopic. Next week when we start, we will start with a new subtopic lah. Okay, I realized that I'm actually one of the slowest teachers of all the 3 physics teachers kan. Saya lah yang paling lambat. But it's okay. I think it's more important that we understand lah. Okay, at the pace that we are comfortable with. Okay, so are we ready? Question number 1. A trolley of mass 2 kg being pulled by a force of 6 Newton, okay, at an angle of 60 degrees from a horizontal smooth floor. Okay, what is the horizontal component of the force? I'm going to say Lester since I called Lester just now. Lester?
6 cos 60 equals to 3 Newton.
Okay, 6 cos equals to 3 Newton. Okay, this will be Fx lah. As in the horizontal component, right? We call it F horizontal. Okay, some books now will call it Fx also because x is the horizontal axis. Okay, paksi x lah. All right, good. Question B, what is the acceleration of the trolley? Who was the second to enter? Wilson.
Oh, hello.
Hi.
Which question, sir?
1B.
Oh, okay. 1.5 ms negative 2.
How do you get the answer?
3 equals to 2a.
3 what? 3 equals to 2a.
Yeah.
Okay. This is from which formula? What formula do you get this from? Wilson?
Huh?
What is the formula you use to do this?
F equals ma.
Okay, very good. But how come the F only we consider the 3? Why is there no minus something?
Smooth.
And usually F is the resultant force. It's front minus the back. But why do we? Okay, because it's a smooth floor. Smooth floor means?
No frictional force.
Okay, no frictional force. Okay lah, fine. Frictional pun boleh. Okay, so what's our answer? A will be 1.5 meters per second squared. Okay, all right, good. So this is correct. This is correct. Allah hai. Okay, question number 2. A man pushes a lawnmower with a force of 100 newtons. Okay, indicate and label the force F exerted by the man on the handle of the lawnmower. Actually, it's already indicated here for you lah. Okay, so you just have to draw the arrow and then write the letter F. Okay, then the direction of the horizontal force and the vertical force of Fy. So this one is, as I said before, we need to consider if the direction of the force is like this, what are the 2 directions that cause it to go this way? It will be downwards and leftwards. Leftwards. Okay, downwards and leftwards lah. Okay, so this downwards is the horizontal force, Fx. And this leftwards is the vertical force, Fy. This is the F. Okay. Don't forget this, because different directions of force will give you 2 different components. Dia bukan selalu, up and right, up and right. Dia bukan selalu begitu. We have to consider the direction of the force that is exerted. Okay, remember the 4 directions that we talked about. If it's like this, if it's like this, if it's like this, and if it's like this. Okay, so each one has different horizontal and vertical components. Okay, important for us to remember. All right, find the horizontal force. Can I have Adam, please, for this?
Um, 86.6 Newton.
86.6 Newton. Can you tell me how you got that?
Fy equals to 100 cos 30.
Fy. Horizontal or?
Fx
Okay, Fx equals to
100 cos 30.
just give me a moment. 100 cos 30. Okay, 100 cos 30, and you will get this answer 86.6 lah. Okay, good. The vertical force.
The vertical force is 100 sin 30, which is
Okay,
50 Newton.
50. Okay, 50 newtons. Okay, thank you. So what is the function of each component? I'm going to leave this to anybody who wants to answer. Can anybody think of an answer for this? Anybody? What is the function? What is the function of the horizontal force? What is the function of the vertical force? Anybody thought about it?
To reduce frictional force.
To reduce frictional force is which one? Fx or Fy?
Fx.
Fx, Fx to reduce frictional force. Okay, I'm going to up your game a little bit. So to reduce frictional force is very good. Okay, it's a good answer. Okay, but we need to talk about how it reduces frictional force. Okay, so you can use Elijah's answer, which is a very good answer. I'm going to push it a little bit further by saying to reduce frictional force by moving the lawn mower forward. Okay, so by moving the lawn mower forward, there will be an acceleration, and that's why the frictional force will be reduced. Okay, so Elijah's answer is good, but let's just stretch it a little bit further to make it even more cantik lah. Okay, and this one is obviously there akan ada frictional force lah, because it's not a smooth surface. Come on, it's the grass. Okay, grass definitely got this one. Okay, how about Fy? What is the function of the vertical force, you think? It's okay. So the frictional force, sorry, the vertical force downwards, okay, the function is to increase the downward force. Okay, to increase the downward force. Why do we want to increase the downward force? Because the lawnmower needs to be as close to the grass as possible so that it can cut the grass lah. Okay, I'm not sure how many of you have lawnmowers here, but if you have a lawnmower, you know that you really have to push on the ground, in order for it to properly cut the grass lah. Kalau kau tolak ke depan saja, kan, then there's nothing pushing it towards the ground, kan, you will find that your grass won't be properly cut lah. Maybe ada yang panjang, ada yang pendek. So by pushing it into the ground, you are adding more downward force, which is good for the lawnmower. Okay, so that the lawnmower can do its job much easily lah. Okay, so that's the function of the vertical force, to increase the downward force. Sorry if you can't see it, let me zoom in for you, my ugly handwriting. Okay, to increase the downward force. Okay, now if the lawnmower weighs 300 newtons, what is the total downward force on the ground? Elijah lah, since you already answered just now, can you answer D also? What is the total downward force on the ground?
+50. 350 apa benda Newton.
Okay, very good. So 300 plus 50 will be 350 apa benda ni Newton. Okay, so that's good lah. Alright, very good. Now, if the lawnmower is pulled, okay, sekarang dia tarik. Okay, what is the total downward force on the ground? Now, if you pull it, the upward force now will be 50 newtons also lah, but on the other side, negative 50 newtons. Okay, dia akan menjadi terbalik. So, my question is, what is the total downward force now kalau kita tarik? Sorry, Eliska?
250.
How do you get 250?
300 minus 50.
Macam mana? Okay, 300 minus 50. Sebab dia punya force sudah berlainan arah. Okay, so it's 250 newtons on the ground, which is not very good lah. Okay, that's why when you use a lawnmower, you push. You don't pull on the lawnmower. It's very strange to pull. Okay, because when you pull, you are pulling the lawnmower up and you're making it hard for the lawnmower to do their job. Okay, all right, good job. Let's continue. F, which method of moving the lawnmower is more effective to cut the grass? This one I've already answered. Pushing. Okay, because what did I say just now? Okay, because the total downward force is greater. Okay, total downward force is greater, and the lawn mower can cut the grass more effectively. Oh dear, sorry. Okay, look at my ugly handwriting. Okay, so the pushing force is better. Okay, the pushing force is better. Okay, because the total downward force is greater and the lawnmower can cut the grass more effectively. Okay, or if your answer is similar to this answer, it's okay lah. Okay, saya punya jawapan ni pun boleh diterima. I think kalau kamu punya jawapan adalah lebih kurang sama kan, don't have to write the entire sentence again lah. Okay, bukan jawapan kamu salah, just maybe your explanation is a little bit different from mine, but it's totally fine. All right. Okay, good. Question number 2. Can I move on? Can I continue? Because I kind of want to finish all the questions if possible. Okay. All right. A car of mass 1,500 kilograms is on an inclined road at 30 degrees from the horizontal. Okay. Calculate the weight of the block. Okay. Calculate the weight of the block, please. Melanie lah, since kamu teriak dalam telinga saya tadi. Weight, please.
The weight of the block to weight of the car bahkan.
Yeah, weight of the car. Sorry.
1,500 times 9.81 equals to 14715.
Okay, 147. Tepat-tepat ke this? Is it tepat-tepat?
Yes, sir.
Okay, 14715 newtons. All right. Okay, so the weight. So this one, ini salah sudah lah. Okay, this is 14715. So we know that over here, the weight is the saying force. And when we resolve it, it will be sine 30 here and cos 30 here. What is sudah bagi or all these tips? Okay, the weight component which is parallel to the road. Parallel to the road means do we want mg sine 30 or mg cos 30? Melanie, you're going to answer this whole question, so you might as well just answer.
mg sine 30.
Okay, so we want to find the wx lah, the horizontal component. Okay, so mg sine 30, atau kita tidak pakai mg, bahkan kita pakai w sine 30. Okay, so this will be 14715 sine 30. Okay, which will give us
7357.5.
Okay, unit
Newton.
Newton. Very good. Okay, so now the weight component that is perpendicular to the road. Kalau parallel is sine 30, perpendicular will be cos 30 lah. Okay, 14715 cos 30, which will be
12743.56 Newton.
okay, very good. So the resultant force, let's talk about this. Resultant force. Apa ini? Along the road. So the resultant force ni kita mau ambil kira apa?
Wx minus with frictional force.
Okay, so Wx minus the frictional force, which is 7357.5 minus berapa dia tu? Frictional force?
2,500.
2,500. Okay, so how much?
4857.5.
4857.5. Hold on, Okay, 4857.5 newtons. And what is my acceleration?
F equal to MA. So
Okay.
4857.5 divided by 1500 kg.
Okay, so A is?
A is equal to 3.24 ms negative 2.
Okay, 3.24 ms negative 2. Okay, so far so good. Now, last one, state the change to the car's acceleration if the road becomes steeper. And why does it change that way?
Saya
What
kan
is your
masih.
Ya, kau masih.
Okay.
Minggu lepas kamu hilang suara kan, jadi hari ini kau tebus balik semua lah.
The acceleration will increase.
Okay,
Then the bigger the angle, the bigger the downward force.
okay. The bigger the down. Are you sure it's the downward force? Downward force is ini tahu. This is the downward force. Okay, so better to use this word, the weight component which is parallel to the road. So ini yang sebenarnya kita guna dalam kiraan kan 737.5. Ini yang berubah sebenarnya. The friction doesn't change. Okay, the friction doesn't change, but the weight that is component, the weight component which is parallel to the road, the WX, okay, will increase. Saya baru sedar yang suddenly my head become very small. Sorry. So the WX will increase, okay, because the weight component parallel to the road increases. Okay, so the acceleration will increase sebab yang weight component yang WX itu akan meningkat. So menyebabkan the acceleration to meningkat. Okay, very good. Sorry, let's continue. I think Brandon just now he said B cadet.
No, sir. A lah. A, bukan B.
Okay, can you tell me how you got A? Can you tell me how you got A? Did I disappear again? Sorry. Tahukah Brandon macam mana mau dapat A?
The resultant force divided by the mass.
Okay, how do I find the resultant force?
The resultant force. First cari yang the horizontal force, which is
Okay.
30 cos 60.
Okay.
Then dapat 15 Newton.
15. Okay.
Yes. And then
Okay. Okay. And then?
the resultant force is the resultant force 15 minus 5, which is the frictional
Okay.
force.
All right. Then you get 10 newtons.
Newton. And then divide by the mass.
Okay, so F equals to MA. So 10 equals to 4 divided by A equals to 2.5. All right, very good. Okay. Excellent explanation. Okay, number 2. Angeline?
C.
C. The total downward force is F minus Fx. Are you sure? This is the force going this way. This is the downward force over here. Fy. Because she's pushing the trolley, just like the lawnmower just now. So how much should it? This is F, this is mg, this is fx. Want to try again?
A.
Yeah, okay. This is the answer, Fy plus mg. Because both are the same direction. Okay, of course, if this was going up, if let's say Fy is upwards, then it will be mg minus Fy lah. But because both of it is going the same direction downwards, okay, so we plus it together. Okay, all right, very good. Next, diagram A and B shows two ways in which a gardener moves a wheelbarrow on a muddy road. Okay, you know what? I'm going to draw this first. So the direction of the force exerted by the gardener. So in diagram A, the direction is this way. Okay, this way is the direction. In diagram B, the direction is this way. Okay, so if we break it up into the horizontal and the vertical components, yang di sebelah kiri, this will be down and right. Okay, fx and fy. Manakala, on this guy, it will be up and right. Kan? The thing that we've studied since the beginning, kan, we have to always break it up into two. Okay, kalau dia upright, then it will be up and right. Okay, kalau dia down right, it will be down and right. Okay, so that's the direction of the force exerted by the gardener. So, the direction of the vertical component, okay, done. So, based on the answers in A1 and A2, which of the ways is more suitable on the muddy road? Okay, explain the reason for your answer. Irdina, can you answer this, please?
Diagram B.
Okay, why?
This is because the vertical component is going upwards, which is going into the opposite direction of weight. Therefore, the resultant force will be smaller.
Okay, it's a very good answer. So, because Fy is in the opposite direction. Okay, opposite direction from the weight. Okay, so the resultant force is smaller. Okay, so the barrow, the kereta sorong situation is very different from the lawnmower situation. In the lawnmower situation, okay, kalau kamu mau potong rumput bahkan, pushing is better. Okay, pushing is better than pulling because we want the lawnmower to be nearer to the ground. But in the wheelbarrow situation, okay, pulling is actually better because you don't want to add the extra weight. Okay, because if you already have to push forward, then ada lagi berat yang ke bawah bahkan. Okay, in this direction, these two add together kan, dia akan menjadikan our wheelbarrow even more heavier. Okay, so that's not a very good solution. So a pulling method is always better. Okay, but think about this lah. In reality, whenever we use a wheelbarrow kan, whenever we're doing wheelbarrow kan, do we actually push or do we actually pull? How many of you have done wheelbarrow before? Think about it lah kan. Biasanya kita tolak bahkan because there's a wheel in front lah. Okay, but actually if you think about it, pulling is actually better than pushing. It's easier on us lah. Okay, that's why kalau orang yang pakai kereta sorong dan dia tolak bahkan, okay, dia akan rasa sangat penat tau because you have to fight against the weight to push the thing forward. Okay, in actual reality, according to physics lah, pulling is better. Okay, because you are reducing the weight, you're reducing this one. Cuma tarik lagi senang. Okay, cuma the problem with pulling is susah kamu mau tahu the direction because there's only one wheel. So I understand why people will want to push because people want to push so that senang untuk macam pandu kereta lah kan. Kalau kamu tarik, okay, kalau kamu tarik susah kamu mau tahu bahwa what if the wheelbarrow at the back there dia punya stability kan menjadi like okay tidak stabil so dia akan jatuh, which is something that we don't want lah. Okay, so I guess it's a kind of balance between both lah. If you ask me, I would rather pull lah. Okay, tetapi mesti ada orang di belakang yang tolong saya pandu the one wheel. Because the problem is the one wheel tau. Okay, the problem is the one wheel lah. Yang satu roda itu yang menyebabkan susahnya mau pandu ini benda. Okay, so which is why if you're alone, maybe it's better to push. But in terms of physics, in terms of resultant force, it's actually better to pull because there's smaller resultant force now. You know, you don't feel so tight if you pull. Unless kamu punya wheelbarrow selalu jatuh lah, which happens to me lah. Okay, I'm very bad at wheelbarrow one. Yeah. Okay, I'm very bad with wheelbarrow. It's just wheelbarrows are not my friend lah. Okay, dulu masa di sekolah lama saya kan, saya selalu kena pakai wheelbarrow lah, angkat this and angkat that kan. It's not a fun experience lah kalau wheelbarrow and me. Okay, apalagi kalau the wheelbarrow dia punya tire tu pancet. It's like the ultimate worst thing in the world. Okay, thanks Irina for the answer. Okay, number 4, diagram 3 shows a box of mass 43 kg. Okay, on a ramp, 20 degrees slope to the horizontal. Frictional force is 147. Let's use 147.1. Okay, we follow the diagram lah. 147.1 newtons. So, first of all, indicate and label the force Wx and Wy. I hope by now you know that Wy is always this way and Wx is always this way. And the angle of 20 degrees is always touching the Wy. Okay? All right. Calculate the weight of the box. Crispia.
43 times with 9.81.
Okay, which is?
4 to 1.83 Newton.
Okay, very good. Calculate the resultant force parallel to the ramp. Resultant force parallel. Parallel means kita kena cari apa dulu? Louis? What do we have to find first? Sorry, what do you have to find first?
Wx.
Okay, tell me how to find Wx. Wilson, can you help us out, please? What is Wx?
421.83 20.
Sorry, I heard 20, but I didn't hear what you said before that. Is it sine or cos?
Sine 20.
Okay, so 421.83 sine 20, and then?
The answer is 144.7.
100 and?
144.7. 144.27.
144.7.
27.
Okay. 27. 144.27 newtons. Okay, so what is the resultant force? Can I go back to Louis? Louis, can you tell me what is the resultant force based on this? Okay, so the resultant force, actually, if you think about it, the downward component is 144.27. Okay, but the upward component, the frictional force, is 147.1. So the resultant force is one minus the other lah. Kalau kamu tulis 144.27 minus 147.1, okay, also no problem. Okay, you will get sorry, what's the answer? 144.27
Negative
minus
2.83.
Okay, negative 2.83 newtons. Okay, can somebody tell me this resultant force is in which direction? Upwards or downwards? Is the resultant force upwards or downwards?
Upwards.
Okay, it's going to go upwards. But, and this is where the last question is, based on your answer in C2, explain what happens to the motion of the box. So you have to tell me what happens, and then you have to explain it. So what happens?
Remains stationary.
Why remain stationary?
Because the frictional force is more than frictional force is more than
is more than
the upward force.
No, not the upward force. More than the yeah, this is hard. Okay, more than the, we can always say WX lah. I think kalau kita cakap WX pun boleh. The frictional force is bigger than WX. Okay. Jangan juga kamu cakap that the box will go up, Okay. It doesn't work that way. Okay. Unless it's a ghost pushing it, the box is not going to go up lah. Okay. It's going to be there. Okay. Is this the last question? Oh, she got so many more questions. Okay. Sorry. So the diagram 11.1 shows a boy of mass 40 kilograms, yada yada. Okay, so the boy is the same, except that the angle is different. Okay, so the first question is, what is the meaning of frictional force? Frictional force is the force that opposes motion. Okay, force that opposes motion. Okay, any force that is opposing a motion is called a frictional force. Okay, based on diagram 11.1a, calculate the component of the weight parallel to the slope of the fume. We're only considering the A diagram, which is this. Okay, because I'm running out of time, I'm just going to ask for the answers. Let me see. Mordecai, can you give me all three, please? 1, 2, and 3. Terus kau bagi dulu.
Negative 392.4 newtons.
Newtons.
Sorry, it's negative 196.2 newtons.
Mana satu ini?
Yang number 1.
Number 1 is? Oh,
Negative
not negative 392.4. Negative
196.2.
0.2 newtons. Okay. Kalau tiada negatif pun tidak apa. Stop going downwards. As long as you understand which one is positive and negative. Kalau kamu cakap ke bawah negatif, then we have to write negative. But if you didn't write the negative, make sure you understand that downwards is positive. Okay. Resultant force. Teruskan more.
76.2 newtons.
76.2. Acceleration.
1.905.
1.905.
Yes.
Okay, hold on. Sorry. Okay. 1.905 meters per second meters per second squared. Okay, so using the concept of force, explain why the boy slides down in the flume when the angle of inclination is 30 and remains stationary. So ini the same just now the same thing just now. So I'm just going to give you this one. So the first point is the WC. I'm going to call this WC lah. Okay, based on this. Sorry. Okay, so this is WC. So the first one is WC is more than the frictional force. Okay, that's the first point. Second point is, hold on. Second point is, so the resultant force creates an acceleration because dia punya resultant force adalah lebih daripada kosong. Okay, then the third point is the balik law. WC is equals to the frictional force. Okay, and then fourthly, the resultant force equals to 0. So the boy is stationary. Okay, the resultant force is 0, so the boy will be stationary. So this is how you will get the 4 marks now. You talk about why the 30 degrees dia boleh berjalan because the angle will create a WC bigger than the frictional force. And then in the second one, on number 3 and number 4, okay, WC is equal to the frictional force, okay, which is in this case, WC and frictional force is about the same. Okay, so that's why this one will not this one lah. Okay, that's why the boy will be stationary. Okay, there is a slight problem with this question because Actually, when you calculate, sorry, actually, when you calculate, the resultant force actually is not zero lah, because we are using 9.81. So when this question was formed, masa soalan ini dibina, okay, this question is actually old syllabus lah. We used to use G sama dengan 10 bah. But nowadays we don't use G equals to 10. Okay, G equals to 9.81 lah. Okay, but so that's why actually this question I forgot to mention lah. You didn't have to answer this question lah. Okay, yeah, because when we, yeah, I know it's a very strange question. Okay, so when you calculate, actually there's a slight difference lah. Okay, but the point is still the same. Okay, at a smaller angle, okay, if the boy doesn't move, means the WC and the friction is the same value. Okay, at a bigger angle, the WC is greater than the frictional force. Okay, so it will obviously slide down. All right. Okay, last question. Is this the last question? Oh dear. Okay, so lawnmower. So lawnmower, I'm not sure if I have pernahkah saya dedahkan kamu kepada soalan jenis begini? How to do suitability questions. Have I taught you all before how to do suitability questions? Like what is the
Pernah yang
answering technique for
ais-ais
this?
tu kan.
Oh ya, yang hit itu kan? Okay. So, let me just give you this one lah. So the first one is the characteristics. Oh sorry, kita pakai aspect lah. So let's use the word aspect. Sorry. Since we are aspect, then we use aspect lah. Okay, so there's aspect, and then after that there is the explanation. Okay, so the first one is method. Method of moving the lawnmower. Okay, so the method of moving, is either push, pull, or push. Okay, push, pull, 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 or push. So which is the best aspect? Okay, we talked about this earlier lah. Okay, the method of moving the lawnmower is to push it lah. Okay, and why is that so? I've already explained this in the question just now, but the shorter answer will be the vertical. Sorry, my fault. To increase the vertical component, okay, of the force. We want to increase the vertical component going downwards. Okay, so that's the first one lah. I should like draw this properly, man. Yeah. I'm not sure if you can hear this, but the school is already singing already lah. Ramai sudah murid menyanyi, murid form 5. Gembira betul. Okay, mass of the lawnmower. Mass of the lawnmower. Okay, let me see. 5 kg, 10 kg, 5 kg, and 10 kg. Okay, so when we answer mass, we don't say the number. Okay, we usually say small or big, higher or lower. So we want the mass of the lawnmower. What do you think? Should we have the lawnmower small mass or big mass?
Big mass.
Why big mass?
To increase the total downward force.
Okay, to increase the total, that's a good answer. Okay, to increase the total downward, downward force. Okay, or you can also say to increase stability. Okay, that's also a good answer lah. Okay, explanation. This is very unique, this question. Usually kan, we want the mass of something to be small. Kita mau dia punya jisim kecil kan, supaya dia ringan lah. Okay, but in this case, we want it to be big because we need that big downward force so that we can really push we can really cut the grass better. Okay, so that's why the mass of the lawnmower should be big. Okay, the third aspect. What is the third aspect? The third aspect is the size of the cutter blade. Okay, size of cutter blade. Okay, let's see what the options are. Okay, begini dia punya size atau begini dia punya size. Big or small? What do you think? Should the size of the cutter blade be big or small? Anybody? This is very, no need brains one. Everybody also can answer this. What do you think? Should the size of the cutter be big or small? Okay, why should the size of the cutter be big?
To cut more grass.
Yeah. To cut more grass. If the size of the cutter is tiny, bahkan, you know how slow you have to travel? You're like, oh, okay, is this grass done? You travel. Like the size of the cutter is very big kan, dia boleh memotong lebih banyak rumput pada satu kali. Okay, guys, this line got nothing to do with physics, It's just logic and common sense. Okay, not everything has to be physics answer lah. Sometimes, just using logic and common sense will also help you with this answer. Okay, because this is a problem solving question. Okay, it's not really, it's a physics related problem solving question, but sometimes a lot of problems can be solved by just using basic logic. Okay, but last one, angle between the handle and the horizontal line. Okay, this one is definitely physics lah. Okay. So angle between, okay, yada. Okay, should it be a small angle or big angle? What do you think? What do you think? And the horizontal line, okay, is big or small? Big or small angle? Anybody? Wow, guys, we have talked about this subtopic for so long already. Okay, Elijah says big. Of course, the answer is big. Why should the angle be big? Why should the angle be big? What do we want? What do we want to create by having a big angle? Think of the boy on the slide just now. Right? Easy to push, less effort. Because those answers are okay. Okay, easy to push, less effort. Because why? Let's draw it back to physics. Why is it easier to push if the angle is a lot bigger? Not too big, but bigger, big enough. Why is it easier to push? What do we want to increase? Anybody?
To increase the downward force.
Okay, very good. To increase the downward force. Because when you increase the downward force, okay, then it will be easier to push. Okay? So, after you have done this entire table, then you have to determine the most suitable lawnmower. So, which lawnmower has a push, and then the big, and then the size of the cutter is big, and then the angle is big? Which one? Is it K? No, it's not K. It's probably M. And it is a push. The mass is big, the angle is big, and the size of the cutter blade is big. So the most suitable lawnmower is M. Okay, so this is a 10-mark question, by the way. So this is 1 mark. Okay, so the reason, okay, whenever you write the reason, you write all these 4 things all over again. Okay, the reason, the method of pushing, yada, is big. A is push. Okay, And then after that, what's the second one? The mass of the lawnmower. Mass of lawnmower is big. Okay, and then you complete all the